Folks, we're getting a lot of people starting to join so far. We're getting it more. I appreciate you guys being here for our February PHMass meeting. So welcome. You've seen Christina McPike here on your screen talking. She, for Wind Companies, is going to give us a presentation tonight on several retrofit projects she's been involved with. But I want to take a time just to give some quick updates before we get started. Some of you may already be aware, but this morning the DOER released their draft of the new stretch code updates for the state. This caught a lot of us by surprise that they were doing it this quickly, releasing it this morning, but they did. And so it's out there. This has been, many of you have heard us in these meetings for the last year discussing the topic of the net zero stretch code. And that's what this is the update to the Massachusetts state stretch code, as well as the creation of an additional opt-in code that goes beyond the stretch code, even further than the stretch code goes. And that additional code is what is referred to by many of us as the net zero stretch code, even though its official title does not feature the word net zero. This proposal just came out. Let me see, I actually have one slide here that I grabbed just to show you that passive house is featured very prominently in this proposal, which we were excited to see. This is just showing you the specialized opt-in code, which is, again, what they're calling the net zero code, specialized opt-in code. This is on the commercial side of things, but in terms of this type of code, commercial includes multifamily residential projects. So in here, you can see large multifamily buildings will be required to be passive house under the new specialized opt-in code. So this is just one screen, just one slide, just to show you kind of a highlight. There's lots of things featured in this presentation. We just had a board discussion for the PHMass board. We were kind of going into this. We have a lot to look over, and we'll have some emails going out about this, kind of telling you what we think of this all and what we're looking to kind of comment on for this. But they will be taking comments on this proposal up till March 9th. So sort of their first round of comments. You can go to our website, phmass.org/policy, and you can see a link to this whole presentation, as well as the email address where you can send comments to. That's already on there. In addition to this, you'll see something on there about the allocation of ARPA funds. I sent an email out last week that many of you may have seen, but we're advocating to our state legislature right now, to our senators and representatives, to allocate 5% of ARPA funding to retrofit deep energy retrofits in buildings. So it ties in nicely with our retrofit topic tonight. But you'll see that on our policy page as well, and you'll get a summary of what we're advocating, what the ARPA funds even are, where that money should go, and how you can make comments. But please, folks, take some time to look over this material. We'll have a lot more to say about the stretch code stuff as we get a chance to really digest it. But I wanted to make sure everyone kind of saw it here tonight and knew that this proposal that we've been talking about for the last year or so is out. So with that, I want to welcome our featured speaker tonight, Christina McPike, who is from Wind Companies here, but she's been involved in a lot of passive house retrofit projects and near passive house retrofit projects. So tonight we wanted to welcome her here to talk about her experience on some of those. Christina, I'm going to turn things right over to you. I know you put a lot together here for this session, and I really appreciate taking the time to do it and kind of put together a few different presentations, a few different projects. So we're excited to see what you have to go with. While we go through this presentation, please just go ahead and use the chat room to ask questions and discuss things. And at the end of the presentation, we'll open it up to questions from everybody. But Christina, take it away.
Thanks, Aaron. Just waving at Michelle, whose friendly face just popped up. Hi, everybody. Let me figure out how to share my screen here. That one. All right, and then I'm going to click this button, I think. How's that, Hank, who's unmuted, or Aaron? Good. Excellent. Well, hi, everybody. I'm Christina McPike. I'm the Director of Energy and Sustainability at Wind Companies. We're a 50-year-old family-founded, operated real estate developer and manager. We own about 100 sites, 15,000 units in the Mid-Atlantic and Northeast. And we're a much bigger landlord. We manage another 100,000 or so apartments in 23 states and DC. We've had an in-house sustainability department before my time, for 15 years or so. And we're 2 people and growing, so please apply to our jobs. You'll find it on my LinkedIn and on the company website. And we interface with our development company as well as our management company, ensuring that every project that we do, whether it's an acquisition, rehab, occupied reno, gut rehab, new construction, historic adaptive reuse, is first and foremost compliant with call it what you have to do, and hopefully a lot better than that. We also have developed 3 megawatts of solar PV and a recent DOE Grid Interactive Efficient Buildings grant recipient, which means that we're going to learn a heck of a lot about battery storage and connected devices over the next 3 or 4 years across Massachusetts. So Hank called me and said, can you present on all of your passive house retrofits? I'm like, I don't have any passive house retrofits, so no, I don't think so. But we had a fun conversation about what we are working on and what we can present on. I'm trying to get rid of a little window on my, there we go. Despite not having, let's say, capital P, capital H passive house retrofits, we are and have worked on some really exciting existing building retrofits. I'm going to share 3 of them today. 2 of them look pretty similar. They're historic adaptive reuse projects, which I wouldn't normally qualify as a retrofit. It's basically building a new building inside of an old building with a lot of federal and state historic oversight. And one occupied renovation project that is going to look and hopefully remind everyone of the ARPA funding request and advocacy work that Aaron just mentioned, led by Rocky Mountain Institute and the 1,000 Apartment Challenge. So I'm going to start there because it's my favorite project and we're super proud of it, and I'm excited, extremely excited about it. So Eva White Apartments here up on the screen. This is going to be an occupied RAD conversion, a rental assistance demonstration project, meaning Wynn and our nonprofit co-developer, Castle Square Tenant Organization, are acquiring this property from the Boston Housing Authority, who owns it today, and privatizing it. All the residents who live there now will stay there. This is an amazing HUD program that effectively recapitalizes public housing. We're doing this with a whole bunch of partners. Only a select few are listed here. Rise Design Associates is the architect. We have funding from the U.S. Department of Energy's Advanced Building Construction Initiative. And again, Rocky Mountain Institute really brought us their Realize concept almost 3 years ago now and said, wouldn't it be great if you did an all-electric deep energy retrofit project using prefab components? And said, yeah, definitely. How do we do that? And 3 years later, we're about to submit or pull a permit or submit for ISD review of that permit, and hopefully close on financing and start construction late spring or early summer. So the project is 2 buildings that is on Tremont Street in the south end of Boston. It is kind of funny, 12 years ago or so, Wynn did a deep energy retrofit, or what was classified as a deep energy retrofit at the time, of Castle Square Apartments, which is the sort of white and gray mid-rise buildings that you can see. You can't see my cursor here along Tremont Street, and we just kind of leapfrogged over Eva White Apartments and kept going. And so the Boston Housing Authority retained ownership of these 2 7-story towers that are kind of situated one building on Tremont Street, physically connected to Castle Square on either side, and then a standalone tower right behind it. Buildings are pretty much identical, 102 units, occupied, elderly, extremely low income. So we met with Rocky Mountain Institute. We learned about Realize, which is similar to Energy Sprong, similar to Retrofit New York. Got really excited about prefab components and wanted to identify a really strong candidate building and project where we could electrify systems and achieve really meaningful savings. And Eva White was, one of a dozen upcoming acquisition rehabs in our pipeline, in our portfolio. But it was a really good candidate for a few reasons. First, structurally, it is brick and block. Geometrically, it's very simple, sort of plain. And we had these 2 relatively small boxy buildings where we could contingent upon financing, just choose one of the two and keep costs down and still learn a lot along the way. So working directly with Rocky Mountain Institute, we have developed a scope of work, which I'll get into in more detail with the leadership of our own team internally and certainly from Rise and Design Associates, who's the architect, and developed a scope of work that is projected to reduce the site energy by 68%. Pretty significant, and again, fully electrifying all of the systems. And we're, I cannot wait for phone calls from the residents of the South End when they see all of the refrigerant lines and ductwork on the outside of this building before we're able to clad over it. But these are some renderings from RDA that I thought I'd share. Existing condition over here on the left, you can sort of see there's like a T, we call them the T-shaped windows. There now, all of the new mechanical equipment will be located up in the penthouse and on the roof. I should say the mechanical engineer is the best in the region. This is Peterson Engineering, and all of our new distribution systems, i.e. the supply ductwork off of the ERVs and the refrigerant lines from the central VRF plant, we're going to drape over the existing face of the building and punch through those the T's of the T-shaped windows, where they'll connect to new fan coil units inside the apartments and provide distributed fresh air through the central ERV systems up on the roof. So once all of this HVAC distribution is installed, we'll start hanging our panels. We selected a manufacturer called, that everyone will be familiar with, Trimco of the Drive It brand. This is feels and kind of looks like EFIS. These will be 8 foot tall by 13 foot wide, prefabbed panels fabricated in a shop in Indiana, shipped to the building, and mechanically fastened to the facade at the conveniently exposed concrete floor slabs on each level. And so that's going to sort of completely enclose that mechanical distribution network behind it. The little pink boxes represent our fire stopping detail at the window openings. We'll also actually, just based on ISD and BFD feedback, be fire stopping at each floor slab as well to compartmentalize flame spread. But a little bit more detail here, and we're a little further along in developing drawings. But like I said, we're working with Trimco. This is a new product that they've been, for the last year or so working through R&D of. It's called the Revitalite system. Our panel will be 6 inches thick. It has an internal framing system, and then it's basically coated with traditional EFIS finish. And like I said, mechanically fastened to the slab. The fastening system is a patent pending system, so I can't get into too many details on that. The system itself, meaning the whole panel, the window within the panel, and even the panel to panel connection, it's important that we define it as a system, and a system that is fully engineered and a system that's fully warranted as a system rather than a component level or sort of kit of parts. Is still going through performance testing. We do have the big one, which is NFPA 285, that's the fire test, but it is currently, still going through air, water, and thermal testing and some smaller fire testing, some little sisters of NFPA 285. We're also having the very fun, legalese conversations around warranty and insurance, which is all of our favorite parts of designing and constructing buildings. But when we're in the territory of hanging 800-pound panels on Tremont Street, a pretty important topic. HVAC I touched on, where it's all central systems now and master metered, with the exception of air conditioning, which is tenant owned and provided window units. But it is master metered, including for electricity, which is pretty common in public housing. And that was important to maintain. So we had no intention of sort of pushing utility costs onto residents, and for a variety of reasons, decided to stick with central systems. So we have a central VRF plant, ERVs providing fresh air to every living room and bedroom. We're able to reuse the existing exhaust ductwork, which is great. It'll all be cleaned and aero sealed, and there's some damper requirements required here and there, and tied into the new central ERVs. And we're electrifying the hot water plant. So this will probably be our first Mitsubishi QHB heat pump water heater, although not the only one in design development, given all of our passive house projects are specifying that these days. And yeah, and I have some notes here, sort of space constraints and units, distribution studies. We had this grant from the Department of Energy, which is kind of its own R&D grant. So we didn't have funding for Trimco or the manufacturers to R&D their product, but we did have funding to, as a team, with Peterson Engineering, with O'Day Engineers, with Building Envelope Associates, Horizon Design Associates, New Ecology, spend a lot of time throwing ideas at the wall and seeing what might stick. And some might call that integrated project design or project delivery. It was a lot of meetings and phone calls and brainstorming and charrettes. And we tried a lot of different solutions, and we would pick one that we liked and take 2 steps forward and then throw it in the trash and try over again. So we evaluated, in-unit ERVs. We considered 1-for-1 heat pumps. We looked at floor-by-floor heat pumps. We tried snaking the distribution every which way on the outside of the face of the building, on the inside, and evaluated the implications from, coring and demo and abatement and resident disruption. The goal was always to keep residents in place, and we're planning on doing that. And in large part, that influenced the decision to stick with central systems. It's an expensive retrofit. We're spending about $250K per unit. That's all in, meaning kitchens and bathrooms and non-energy work is included in that number. And it is a union project, but the deep-range retrofit cost alone is a little over $8 million. So it's not insignificant by any means, about $80K a unit. And we had to fill that gap with a variety of sources, but honestly, we were able to do that primarily with called traditional housing subsidies and not necessarily special or new energy monies. That said, we did work hand in hand very closely with the LEAN program, with National Grid and Eversource almost on a daily basis for 4 to 6 months, evaluating the project, the measures, evaluating our energy model, redoing our energy model, vetting our energy model, you name it. And the LEAN program is supporting the project with a significant incentive, which we're extremely grateful for. For every extra dollar you spend on a LIHTC deal, the LIHTC equity goes up. So that's always a positive relationship. And then most interestingly, because we're spending so much money, because the needs were so great at the building, which we could prove, we were able to qualify through a Section 18 path under the RAD program, which is in here in quotes, demolition and disposition of public housing. So this is a program that allows you to underwrite market rate rents in order to support larger and cheaper debt. And that's what we're able to do, and the deal can support it. That doesn't mean higher rents for residents. That just means basically higher rents for HUD. And that is like the main way that we were able to fill the gap in the more expensive project. And like many affordable LIHTC deals, this was the third attempt at getting it funded. So we had full design drawings, basically 70% CD set that had been rejected twice before. And then the third time we decided to go in with this revised scope of work. So we were able to show a portion of the deep energy retrofit scope in our DHCD application. But actually at that time, we were only considering doing it at one of the 2 buildings. It's the RAD Section 18 program that allowed us to basically double the scope, double the cost, and do the deep energy retrofit scope in both buildings. And the scope's identical with the exception of hot water there. This is just a detail, but the both buildings has its own central boilers. They're 40 years old, atmospheric and efficient boilers. But the domestic hot water heaters were replaced 5 or 6 years ago through the lean program. They're high efficiency Lochinvar Armor water heaters. So we're not going to electrify the rear building's domestic hot water plant. We're going to keep it as is and not touch it, which I think will be interesting. We'll be able to compare performance and operating expenses between the new heat pump water heater plant in the front building for 40 Tremont against the 6-year-old condensing gas system in the rear building. Okay, so the second project is the Tyler. This is finished. This is fully occupied with a years-long wait list. This is a historic adaptive reuse that we did in East Haven, Connecticut, and following PHI's Enterfit program. Saying following because we're still begging for certification and going to give up one of these days, but in full transparency, did not end up getting certified because of our blower results, which I'll get into. So this is just a sort of bad Google Maps aerial shot. Boxed in red is our building. The wing on the left side image we tore down. That was a 1970s construction and didn't qualify for historic tax credits, and we didn't need it. Everything behind the red boxed area, the city of East Haven owns and kept, and they use it for sort of town programming. There's a swimming pool and an auditorium and stuff. So we rehabbed the 1936 wing and the 1964 wing, converting those this former high school into 70 new apartments. We elected to pursue the Enterfit program in direct response to Connecticut CHAFA, Connecticut Housing Finance Authority or Agency, their QAP, which at the time, I think they had a total of 6 points. Today that's 13 or 14 points. And at the time gave 3 points for Passive House. Today it's I think it's 4 for Passive House, 3 if you add LEED Platinum on, another 3 if you're all electric with battery storage, and another 3 if you commit to commissioning, benchmarking, and broadband. But 5 years ago, this was the 2017 QAP, and we decided to propose Enterfit as a compliance path. At the time, we were kind of peeved because we felt these points are only going to be available for new construction projects. There's no way we can get them. There's no way we can compete. But we had learned about the Enterfit path, proposed that to CHAFA, and they awarded us the points. Which we to this day feel is the only reason the project got funded through the LIHTC program to begin with. So these are the Enterfit performance requirements, not unlike FIAS, although a little more forgiving. And again, I want to admit these are from 2018, 2019, and they may have changed. I don't know. But sort of maximum peak demand and infiltration requirements and some prescriptive requirements around ERV performance. So there's actually a mix, this is a mix of both performance and prescriptive requirements here. And you can sort of pick and choose your battle. Some are mandatory. There's no way around them, i.e. the whole building blower door test results and the PER demand. But you can sort of underperform with windows and walls, et cetera, as long as you can still achieve the whole building energy demand. Enterfit is great as it has some specific exemptions. The first one bolded here applied to our project. They allow exemptions from those prescriptive requirements based on all of these bullet points here, one of them being historic restraints, which we leaned on quite a bit. Some photos here. This is in the 1936 wing. These are the original steel, single pane, really poor performing, massive windows. They're like 15 feet wide by 13 feet tall or something. In the 1964 wing are the beautiful historic curtain walls. Yes, they are technically historic. They're over 50 years old. So there really was not a lot of historic charm, I'd say, to preserve inside the building. The stairwells are about as design, historic aesthetic, sort of as far as the building went. And so we didn't have a lot to give SHPO and PS, and whatever they could hold on to, sure heck bet they were going to. So like Eva White, we applied to CHAFA a couple times, and so we were able to kind of compare the scope impact, or the impacts of deciding to go from our baseline historic adaptive reuse project to Enterfit. It added, at the time was a 6% construction premium, 1.2 million. It didn't break the bank. This table is trying to show the main differences. The main difference was the exterior wall insulation and the heating system. So we went from a central boiler plant, cooling tower with hybrid water source heat pumps, like a Bulldog system, which had been our sort of go-to HVAC solution, to a central VRF for heating and cooling. We kept domestic hot water on gas. We couldn't hit the Enterfit peak demand threshold with the pumping power and with the cooling tower fans. So that was the main driver to convert to the VRF system. We wouldn't have normally insulated the living room walls at all, and that is SHPO and NPS preference. Insulate your bedrooms where people are trying to sleep, but leave your living room walls exposed. We lucked out here because it's a school building. All of those walls were plastered over for the most part. It wasn't a paper mill with masonry. So we were able to push back on that, and we furred out all of the exterior walls. We were still limited to 4-inch maximum depth. We also had to keep the spray foam off the historic fabric. So we first installed a 1/2 inch of continuous rigid insulation, then our studs, and foamed between and a little bit behind the studs. That way, if you ever want to undo what we did, it will be easier to see the original plaster. We already had an ERV in the scope of work, but we had typically only been supplying fresh air to living rooms. So that was just a little bit more ductwork to extend those to bedrooms. We hadn't been carrying AeroSeal for that system. We added that to the scope and needed it in the end, as anticipated. Our roof got a little bit more insulation, not a ton. The slab is interesting. We had to address the slab of the 1964 wing because we were putting apartments in the partially below grade, or like the ground level. And Enterfit has a comfort criteria. Our floor is basically going to be too cold to comply. And so we built up the entire slab or ground floor by 6 inches and then poured new concrete topping slab on top of that. We'd always planned on following the utility incentive programs, HERS requirements for incentives. And so we were planning on testing for compartmentalization, had a pretty normal infiltration target there. For Enterfit, we had to commit to whole building 1 ACH 50. I want to be cognizant of time and leave time for questions. So you're not supposed to be able to read these details. Stephen Winters Associates was our consultant on the project, and we spent a lot of time with them reviewing details. Unlike a new construction project where we're pursuing FIAS certification, we know how to design and detail that wall assembly. We didn't know what was going to be behind the wall that we were knocking down in this school building until we knocked it down, and then saw that there was a big piece of steel behind it, and we needed to address that somehow. And the somehow was usually spray foam, unfortunately, from an embodied carbon standpoint. But this image is just to say that it took a lot of back and forth, a lot of design review meetings, and quite a bit of field inspections and sort of pause and consult type days, where we uncovered some unknowns. Meaning everything feels somewhat customized. This image is just blurry, I apologize, but we had a custom windowsill and head and return product made because we had a very narrow sight lines to play with, and we had to address the condensation risk at the concrete and block wall to aluminum window frame. So again, just kind of a unique attribute of the project. I should mention, I showed some pictures of the windows and the curtain wall earlier. Originally, we were told that we could not replace any of the windows in the building, and instead we had to refurbish them, which would have meant we had to sacrifice the Enterfit standard and the points that we had been awarded by CHAFA. So we spent a lot of time working with SHPO, who was highly supportive of the project and really glad to learn about Enterfit. We had to work with SHPO, which is the State Historic Preservation Office, to really advocate for the project to the National Park Service. And Stephen Winters Associates was able to do a few analyses. One of them here is a comfort analysis that basically proved we would have to maintain 85-degree air temperature to keep people comfortable and to avoid cold spots and issues in the apartments if we did not replace the windows and if we did not fur out the living room walls, because that was also kind of a fight. So it's sort of some neat technical tricks that we were able to use and just sort of have on hand as ammunition for the authorities that be. Similarly, Stephen Winters provided a condensation analysis. They did some thermal modeling of various conditions. Every floor is made of concrete, and all those concrete floors met our brick and block wall. So these were significant thermal bridges, the entire perimeter of every floor area on every level of the building. Not great. And we had to actually sort of drop the ceiling right at those window openings in order to insulate, basically bring our exterior wall insulation up and over onto the ceiling about a foot, and go back and forth with SHPO and NPS on that as well to make sure that it didn't interfere at all with sight lines from the exterior. Can you see your new drop ceiling from the window, and how far back does it need to go? And we had to mock up that whole entire assembly detail for them to show and take pictures and sort of verify that it didn't cause issues. I alluded to foam earlier. There's a lot of it in the building. Unfortunately, it would be great if there were other solutions to avoid that. But we basically foamed every surface that we could, and would often encounter details like this beam here in the picture on the right during inspections that hadn't shown up on any drawings, and luckily was caught before it got framed over and nobody had insulated it properly. Another beam there. So you can see, sorry, all the pictures are pretty blurry, but the far right image just shows how tight and the amount we relied on foam to get those window returns tight against the very uneven concrete rough openings. The image on the left is a infiltration test, a duct blaster test tied to the new windows, which were really, really tight, and manufactured by Universal. So we were unable to get an alternative window to work on this one, and I'll get into that a little bit on the next case study. The windows were a really weak thermal point in the project. We remediated that by sort of window washing. I alluded to that earlier in that comfort analysis slide. But we have all of our heat, sort of the registers almost pointing at that outside wall in order to wash over them with warm air. That's just because our aluminum windows are not a good window. That's something that we had to spend a lot of time with PHI reviewing as well, and we just felt like there was no way around it with the dimensions of the existing steel windows I showed you before. The 90 kW solar array up on the roof. That's pretty nice. So I put the final results here. We were targeting 1 ACH 50, came in at 1.16. We, because of COVID, we couldn't get the curtain walls on the 1964 wing. They were 6 months delayed. And so we decided to do a split CO and finish the 36 wing before the 64 wing, which might make you wonder how you did a whole building test if half of your building didn't have windows in it, which is a great question. And I like to think that's why we ultimately failed. And it wasn't really a failure, but we just had air communicating between the two wings because they were never separated. They were never supposed to be separated. There's a big lobby and corridors on every level connecting them. So we built a temporary wall the best we could. I still have foam stained shirts from the weekend that I spent crawling around in drop ceilings trying to fill the gaps of our mediocre temporary wall. But we did 2 partial whole building tests. We tested the 36 wing and then we tested the 64 wing. We tried to show that the infiltration was really not exfiltration and just communicating between the buildings. But I think we're about to give up on that argument. It was just too difficult to verify. But the team tried really hard and we're proud of the outcome anyway, and really confident that we're not losing conditioned air through the exterior envelope. I don't have much to say about operating expenses here. We can talk about it during Q&A, but electricity is really expensive in Connecticut. The first few months of operating the building were kind of a nightmare. This is this VRF is basically a 2-pipe VRF. It is not simultaneous heating and cooling, so it's a hard changeover system. And our maintenance team, was trying to satisfy every resident need and wants. And we were flipping back and forth a lot. And as you can imagine, straining the system quite a bit and our electricity bills as a result. This past year is already 30% less than our first 12 months of operation. So we're in a much better place now and very well trained up. And Peterson was a huge help in helping our team get there. Okay, so last project that I want to present on is Stone Mill. I see this as the Tyler 2.0. Obviously another historic adaptive reuse project. This building is in Lawrence, Massachusetts. It's a beautiful historic mill building constructed in 1845, 150,000 square feet. We're converting it in largely vacant today. We're converting it to 86 apartments, mixed income, workforce 60% and 30% AMI. And we've committed to an all electric building with no fossil fuels. So the main difference from the Tyler being electric for domestic hot water and heat pumps on the ERVs rather than gas. So we're just in early design now. The project was funded by DHCD last fall. And we submitted with this scope of work. We started really aggressive from day one. We wanted to do that for a variety of reasons. We knew we could do an even better job than what we were able to accomplish in East Haven. And we were, responding and sort of, I'll say responding to the Columbia gas explosions that really devastated the Merrimack Valley, and also presented resources made available through the Massachusetts Department of Energy Resources. So with that in mind, we set out on developing the scope of work here, and we knew we needed to maximize insulation. We knew we needed a better window than we used at the Tyler, and we are a little bit nervous about our operating expenses, but are underwriting a very, very conservative budget for those. These percentages show the modeled savings over a baseline, which is not, it's holding most things equal except for HVAC. So it's comparing our VRF ERV system to like a PTAC system, for example, but significant savings over a baseline condition. So like I said, all electric heating, cooling, obviously ventilation, domestic hot water. We are using a simulated double hung window. So it looks like it's a double hung window when it's closed, which it needs to for SHPO and MPS. But we're hoping we'll have a much tighter air seal than a hung window would. we'll get into some of the installation details. We'll have sort of connected devices here for better demand management. We're setting the same 1 ACH 50 target as Enterfit. We're not formally calling this an Enterfit project. We're not planning on certifying, but we basically used all of the performance requirements of that program to establish the performance spec for the stone mill. It's an expensive project, $31 million. Supply chain has hurt that quite a bit. Our model DUI is 27.6. So here's just some images. There's a lot of glazing. I think it's almost 30%. And you can get a sense of how skinny the meeting rail is between the top and bottom sash. There's a massive attic up here on the top level, which we thought was pretty clever to use as a mechanical penthouse. And so the original scope of work submitted to DHCD, and that's been funded and that we're now redesigning, showed we're basically building a roof inside of the attic, making that attic an outdoor space and putting all of our mechanical equipment in that space, which means we have a lot of fan power and require mechanical louvers throughout that roof line, which is having a pretty big energy hit. Also very expensive structural scope of work. So there's, I don't know how many tons of equipment, but a lot. And the structural reinforcement is extensive. We're also not sure how we would ever maintain and replace this equipment, 10, 15 years from now. So over just the last 2 weeks, we've been working with the mechanical engineer, which is R.W. Sullivan, to try to locate all of that equipment at grade instead. We originally were not doing that because this building is in a floodplain, a 100-year floodplain, and historic doesn't usually like to see mechanical equipment at grade. But we are solving for that. So we're introducing new areaways on the rear side of the building and hopefully relocating all of that equipment to that space. And we're taking what may have been future commercial tenant fit out opportunities and making those into mechanical rooms. And we think it's going to save a lot of money on first cost, but also an operational cost, because we eliminated something like 60 makeup air fans and louvers up in that attic space. Our wall looks different than the Tyler. You probably noticed all of that metal breaking up our foam on the Tyler. Probably two wrongs don't make a right. At the stone mill, everything will be wood studs on the flat. So we're trying to really maximize the R value that we can get out of the exterior wall assembly. And similarly, had to make a case to historic to allow us to insulate all of the exterior walls. So originally, the construction team assumed that all of our living room walls would be exposed. We would just kind of power wash and paint them. Instead, all of the walls will be furred out. They'll all grow 4 inches in depth and receive spray foam insulation between all the wood studs. We're also not holding it off the existing wall with rigid. In this case, it'll all be foam. We've been working extensively to get everybody on board with a window replacement. We just released a mock-up window to be fabricated. Hopefully we'll have that installed in a few weeks and be able to get pictures and prove that it is good enough and close enough to the original windows. We thought we'd found the original windows, and all the windows in the picture were original. We had a very sophisticated window survey consultant come out who is an expert in this particular vintage of building stock. And he actually found that all of the windows that we thought were original were not, and they were installed at some point in the early 1900s. Still historic, but not historic enough. We found 3 original windows in the building, and every new window needs to match those original windows. These are minor differences. I'm convinced no untrained eye would ever notice a difference, but lots of people do notice the difference. So we're working with a window manufacturer called Peerless to manufacture the window. It's still aluminum. It's not a triple glazed window. We floated the idea by historic. There's just no way that we can meet the dimensions of the window with a UPVC product, and we've been talking to Marvin about an aluminum clad wood window, and the performance is over U.30. So we're sticking with peerless, and I'm excited about finding this manufacturer. We've never worked with them before, but the whole window will act as a hopper and sort of push out. So it'll be a really nice airtight closed assembly, which is going to be important for us to achieve the 1 ACH. New Ecology is the sustainability consultant for the project. We received some early funding support from LISC to engage R.W. Sullivan on energy modeling and New Ecology on some technical consulting, which was huge and allowed us to very quickly conceptualize the scope of work for our LIHTC application before kind of getting too far ahead and going down the wrong road or wrong path. This is just a detail similar to what we saw Stephen Winters do at Tyler. New Ecology caught this, which is our window head, and identified it as a mold risk due to condensation. So we're working on beefing up the R value of that particular section of all the walls. I mentioned the floodplain earlier, so we're raising the whole ground level by 8 inches anyway, and so it's a great way to introduce 6 inches of new rigid insulation instead of just fill and concrete. So this note, actually, I noticed when I was putting this together, it says extend a minimum of 4 feet in the horizontal direction, which is wrong. It needs to be under the entire slab. So we will follow up on that. But again, sort of a custom one-off detail, as you'd expect in these historic adaptive reuse projects that are very sort of building specific and require the team to come up with custom details, custom solutions to achieve the performance objectives. So that's it for my slides, and excited to transition into Q&A. Thank you.
Thank you, Christina. That was a fantastic presentation and 3 very, very interesting projects. I think we have a lot to discuss about them, so I hope there's going to be a lot of questions. There's a few in the chat room already, so I'll go through those. But otherwise, for everyone else, you can add your questions to the chat room, or you can use the raise hand feature of Zoom, and I can unmute you and let you ask your question directly. But let me get to a few there in the chat room here to start off with. First, there's one that this was put on here during the Tyler presentation part of it, but I think it applies to all of them. And it's a little bit about the design, bid, build process here. So is your contractor predetermined for your projects? How are you evaluating the cost values for the scope of work if they're not predetermined?
That's a good question. If they ask, they're not predetermined, but they pretty much are. All 3 projects, this is just a coincidence, but all 3 projects that I presented are being built or were built by Keith Construction. That's our go-to general contractor. We do a ton of work with Keith. They're engaged early and pre-construction services so that they know the scope and are participating in scope development and iterative pricing and inevitable value engineering all along. We may have gotten alternative bids on the Tyler. I don't recall. We're not required to, but we have very transparent bidding, in relationship with Keith Construction, similarly to Cranshaw and Delbrook and others that we work with a lot in the state, so that we see subcontractor pricing and can kind of push back. These projects generally have a number that they have to hit. It's a number that we may have committed to a year, 2 years before we actually start building the building. So we're very much a team effort to keep the project costs at that number, despite how scope may evolve.
Great, thank you. Couple questions here about the Eva White project, just some details. So how will you access the duct and pipe risers behind the new facade? And did you need any fire or smoke dampers in the ductwork?
Yeah, I hope we never have to access the ducts and refrigerant risers. We can technically take a fan coil unit off the wall and find an access panel to get to the refrigerant lines that are coming into the building there, and are teeing off of the main risers, which is, if they're leaking, hopefully that's where that's happening. Not unlike a new construction building where they're buried in walls and require demo to get access to. And yes, every duct requires a fire damper where it comes through the exterior wall. The existing exterior block wall is technically we're treating that as our fire rated assembly, even though our new envelope is also fully fire rated assembly. But we don't have dampers within the cavity, so all of the dampers are within the unit where the duct penetrates through the outside wall, which is mostly a window opening. In some cases, it's block.
Right. Thanks. Then there were a couple of questions just related to cost. So the DER cost per square foot. So folks were wondering kind of what it was for each project. But I think the other better question here is what are the factors that have had the greatest effect on this cost for you?
So the wall panel at the Eva White project is the main cost driver. It's expensive. It's brand new, and it's not even manufactured yet, and it certainly has never been installed yet. So I'm hoping that we'll learn a lot. And the goal of one of the many goals of the 1,000 Apartment Challenge and Rocky Mountain Institute's Realize program and NYSERDA's Retrofit New York program is to make sure Eva White's not a one-off unicorn, and we're building a pipeline of dozens of these projects, and we can show the manufacturers that there's demand and good reason to get into the space and good reason to further automate and improve the way that panels are being designed and manufactured, which will hopefully reduce costs. So really good work coming out of the DOE Advanced Building Construction Collaborative, as well as Rocky Mountain Institute's Realize efforts in that regard. That's a high cost item. I think MEP costs are sort of levelized. 5 years ago, I saw a heat pump specified and the contractors like made up numbers, but everyone knows what that costs now. So I don't see that as a main cost adder, but if you compare it to what we would have done anyway, what anyone would have done anyway in an existing occupied renovation, which is to say replace everything in kind, it's really expensive. We weren't installing an ERV to begin with at Eva White. So the incremental cost to go from basically replacing the makeup air unit that just is dumping fresh air into the corridors to an ERV unit is significant. Whereas the panel costs, you're comparing that to what we were going to do anyway, which is replace all of the windows and the roof. And so you can sort of back that cost out of the total cost and come up with an incremental cost. Cost is the main issue. All of this is extremely expensive to do. The historic adaptive reuse projects, it's not a big cost premium. I think that 6% or $1.6 million at the Tyler, that's absorbable. Those are costs that we can make work in the projects. The stone mill has a very real gap right now that we're actively trying to fill. And I'm optimistic that moving all of that HVAC equipment from the attic down to the new areaways, despite added site work costs, is easily $1 million savings. We'll find out tomorrow and report back, but Keith owes us updated pricing tomorrow. So, I think that also goes back to the first question. We're working really closely with the GC to solve for these cost issues.
Great. Hank, I'll let you jump in here.
Yeah, Christina, I am so glad that I talked you into this. You were hesitant. Well, I haven't really done, a certified passive house. You are doing the most amazing pioneering work with these projects. So I think they should all get honorary certifications.
Call up Germany and tell them that.
Yeah, I'm going to call Dr. Feist and tell him. But I wanted to go ask a detailed question about Eva White. Eva White, you're saying that the EUI is going from 96 to 31. And I mean, on the face of that, you should be in the passive house range. Where's the weakness there? Where's the inability to get to a passive house Enterfit standard at Eva White?
There is none. I'm just not calling it passive house. We set a performance target and are following all of the really important best practices of passive house that you think about durability and thermal bridging and infiltration. We're just not calling it that. And I don't have a good answer. I think if there is a tangible benefit to the project to get the plaque at the end of the day, then we do it, but that's not totally clear. I am interested in thinking about that more for for Stone Mill, because I really want to qualify for the new construction passive house incentives. But because Eva White is an existing building, we went through the lean program. We're measuring savings against historic usage. That's our baseline, not new construction code. The passive house incentive program is not a motivating factor at Eva White. We don't yet know how we're going to do a whole building blower door test at Eva White. It's occupied, and that will be tricky. So I could see that as being one of the barriers to actually certifying. We'll do compartmentalization testing. We'll also test the panel from the outside for air and water infiltration, with Intertech or BEA, someone like that. But yeah, I mean, it's kind of a label. We're trying to focus on the building science and the performance. And I'm not saying that to deny the value of having a clearly defined performance standard that everyone is designing to and building to and verifying against. Super important and critical, and all of our new construction projects will proudly get pre-certified and certified at the end. We just didn't really consider it at Eva White.
Right. So what I'm hearing is that if you were able to qualify it for a passive house subsidy or rebate that would add value, then it would be worth something. So you might be trying to do that on the Stone Mill. You might, even though it's a rehab, you may try to qualify it through Mass Save for the passive house incentive.
So the mill projects do actually participate in the new construction program. They always have. So a Stone Mill project would never go through lean. There's no existing boiler to replace. There's a 100-year-old steam plant that hasn't operated in 50 years. So there's no, existing baseline in that way. It's a kind of a tricky territory that needs to be worked out within Mass Save, I think. I am in real time evaluating Stone Mill under the existing, or the current residential new construction program, which compares, it incentivizes your project's modeled savings against a model mass stretch code compliant building, as opposed to passive house certification, which just gets you a per unit sort of prescriptive number, like we all know about. Regardless of the savings, it's not measuring the savings. One would think that we got to those numbers by evaluating savings against stretch code. I'm not sure what happened behind the curtain there, but because we're not pursuing PHMass certification or Enterfit at the Stone Mill, we're currently going through the normal residential new construction program, which is a performance-based program, as opposed to a more prescriptive program like the PHMass program. But that may change.
Thank you. Are there more questions in chat?
Yeah, actually, one just following up on this. I mean, you brought up a interesting point about the challenge of retrofits is also just kind of the logistical challenge of dealing with occupied units. So someone is asking about Eva White, are you displacing tenants at all through this process, and how many days will they be displaced if that's the case?
No one will be displaced overnight. So we've gotten really good at this. We do occupied renovations all the time, where we replace an entire kitchen or 80% of the kitchen in a day and finish it up the next day. But everything is sort of made safe and ready for a resident to come home at 5 p.m. or 4 p.m. That said, they never actually have to leave, but we will make the community room and sort of a host unit available from, during work hours with food all day and stuff like that. So if you don't want to be in your bedroom while a contractor's ripping out your window in your living room, you can go to the community room. But your apartment is always sort of made safe and ready for you to come home and cook dinner and have a beer after the contractors head out.
And that's true for doing the compartmentalization testing as well. You're just doing that during the day before the tenants can come back in.
We do. I mean, we do blower door testing with residents at home. So I think it's kind of cool. COVID is the only tricky part with that. And the whole building blower door test would be difficult because we have to open every door. But if we can just do an apartment level test, the resident can sit there, look at the results and participate. We do that all the time.
That's great. Really good to know. You've kind of been able to adapt to that challenge. So maybe it's not as big of an issue as we think. If there's no other questions here, I want to actually draw from something you just kind of mentioned offhand. You were talking about the first project, and you were mentioning using the air source hot water heat pumps, the heat pumps for hot water. And as we've been moving more to talking about electrification in a lot of projects, especially larger projects, we've been kind of struggling with how to address water. And you mentioned it's kind of standard for you in a lot of your past five projects now to use these heat pump hot water heaters. And I just want to follow up. Is that the case? Are you kind of using these frequently now in past five projects?
Yeah, no, I want to be clear. It's not typical for us. I spent an hour on the call this morning with BEC and Cutler, who's a great design build firm out of Worcester. We're doing a passive house project there, and we still need a little bit of convincing and arm twisting on some projects. That's a unique project in that it's a new construction. It'll be PHMass 2021 certified, but it is attached to the old Worcester Vocational School. So it has a historic component that will not be passive house certified, and we're concerned about operating costs there. But it is typical in that all of our new construction projects have specified an electric heat pump water heater system. And I'd be lying if I said that's because we're trying to squeeze the last bit of fossil fuels out of the building. Connecticut is giving us 2 more points to commit to all electric. We just submitted a big application in DC this morning. Same thing. We got 8 more points for committing to be all electric. We're navigating a city council in Princeton, New Jersey, and they know about electrification and they want to know why we're putting in gas domestic hot water heaters. And the answer probably will be in a couple of weeks. Good news, we're not. Can we have our permit now? So there's a lot of power in, at the policy and planning level. I really want to install one before we install 12. And so that's been our hesitancy. We're totally game to install it at Eva White, let it run for 3 months, 6 months, feel good about it, and copy and paste, do it everywhere. We just don't have a lot of information, and that's kind of scary.
Hank, back to you.
Yeah, so you were showing and sort of apologetically at times all the foam insulation that is being used to solve these problems in the historic buildings. Do you have any sense for what would happen if you were doing a whole building life cycle assessment from an embodied carbon point of view with that? Do you know? Do you have any idea
I
how
don't want to
deep?
know.
I know you don't.
Yeah. I mean, I'm trying to get smarter about this. I just feel like we're just now, we've just now figured out operational carbon and we have to almost take it all back, which I'm being dramatic, but there are probably lots of people on this phone call that are a lot smarter and could take a stab at guessing the answer to that question, Hank. I don't know. I sure as heck hope that we're having a positive impact overall, and maybe some of our operational emissions reductions are being degraded by the embodied carbon impacts of the products we're using. I don't know. We haven't done it. We're going to. If anybody's followed along with the City of Boston's updated Article 37 requirements and expecting or requiring all projects going through that zoning process to do a life cycle analysis, considering embodied carbon of the materials in their building. It's just a reporting function now, as I understand it. But the expectation is that they'll eventually set targets that we have to stay under.
Yeah.
There's a good follow-up question in the chat just now about this is when you are, using foam, are you at all looking at the global warming potential of different types of foam? And is that informing the decision of what product you use?
Yeah, we're using, it's always sold to us and called a low GWP foam product. And there's all sorts of lead USGBC logos on the cut sheets, and everybody says if you're using foam, it's the best foam. So yes, but I'm not a chemist and I haven't studied that in any level of detail. We scrutinized it enough to not, keep me up at night. But that's about as far as we've gone with it. There's a cool kind of injection foam product out by BEM, building evolution material. No, I don't know. The E stands for B something, building something materials. That the Department of Energy had introduced me to a while back. Building envelope materials. Thank you, Emily. That we've piloted at 2 existing buildings. Hopefully, about to do a 3rd one up in New Hampshire. And it is low embodied carbon exterior wall sort of retrofit solution that seems to be pretty promising, and we're excited to try out. It looks like you're sort of pouring shaving cream into your wall cavity, and it hardens relatively quickly without cracking and expanding. And even if you have old fiberglass bats in there, it sort of squishes it down and becomes this really nice, neat, solid insulation barrier.
That's great and good to know. And also, the fact that you're doing all these retrofits to begin with is having an embodied carbon impact, no doubt. You're using existing material, you're reusing that material, you're not demoing the entire project and having to put all that stuff in a landfill. So that in and of itself is a good place to start.
Yeah.
And kind of the reason we need more retrofits to happen. And you talked a lot about kind of policy and incentives sort of pushing you to do a lot of this work. Obviously, we're in the middle of some of that happening in Massachusetts right now. And you've been involved in the ARPA kind of policy work a little bit. I wonder if you wanted to talk about that for a moment. We've been pushing for about 5% of that to go towards existing buildings. But how valuable is that to you? Do you think that would be a large driver in the industry to get more deep energy retrofits done?
Yeah, definitely. I kind of joke to Rocky Mountain Institute and Heather Clark, who's leading the 1,000 apartment challenge. Like, why didn't we call it a 10,000 apartment challenge? I have 5,000 apartments that I want to retrofit yesterday. So yeah, we just need funding to do it. Not only funding, but we need proofs of concept, and we need demonstration projects so that we know what the right scope of work is, what's a reasonable price point, what savings are we actually able to get, especially if we're electrifying everything. and, working out the kinks. So I think that's the answer that I'm sure they say back to me when I say, why not 10,000? Let's do 1,000 first and learn from it, and then do the next 9,000 after that. But yeah, it's extremely expensive to do, especially if you compare the cost of doing nothing, which is what most building owners are doing. And I think Berto 2.0 is going to change things quite a bit. That's a real policy. City of Boston is taking a firm stance on folks complying with that. I don't anticipate there being lots of waivers and easy outs by any stretch. So we're planning for that, and we're the biggest landlord in Boston. You see Wynn, and we do these big fancy loft buildings, but we manage buildings for a tenant co-op who only owns that one building, or we manage 5 buildings for a small nonprofit portfolio owner, and we manage portfolios for big owners like us. And I know the ins and outs of those owners' buildings, and I've been in a lot of those buildings. And if we can retrofit Evo White in the way that we are, and there's funding available, and we know that those building owners are going to be fined in a real way because of Berto in a few years, we need to start planning and advising them on how we can improve their building stock. Yeah, so hopefully we get 5% of a second tranche of ARPA money, but there's also ARPA money out there now. The city and state level can look it up. Your own towns that you live in could very well be sitting on a pretty purse of $20 million that could be earmarked for a project or not. So I think everybody should be advocating for the right use of these funds, and really not waiting for the federal government to show up with Build Back Better.
That's a very great point about some of this happening on the municipal level as well, not just at the state level. Hank, your hand is up again, so go ahead.
Yeah, I had just some kind of detailed questions about the historic requirements. I've heard this before, this 4-inch, is it a hard rule that you cannot do more than 4 inches on the inside?
Yeah, I don't know who proposed 4 inches. I wish I could go back in time and say start with 8 and maybe we can get to 6. It's 4. We've tried we've tried very hard. We built a mock-up wall 6 inches thick at the Tyler in Connecticut and invited everybody down to look at it and sort of prove that it doesn't make that big of a difference, but it's a hard no.
What are they looking at? Are they looking at
volume,
window return depths? What are they concerned about?
Yeah, the look and feel of the original space and the dimensions. Lots of sort of space and volume terms that I think architects would be more privy to than I am, but the feng shui. No, I mean they want to walk into a room and it needs to feel like it did when it was originally built, and the way that a person interacts with it at a particular scale, is intentional, and they want that preserved. And for whatever reason, they've settled for 4 inches. Only in some cases. I mean, we're doing a mill near Hartford right now, and they rejected any wall insulation, like even 4 inches. So we will have none. So it's case by case, and sometimes it depends on the reviewer who's been elected to your region in that year, and
right.
It's frustrating. But it's a really important program, and the historic tax credit was on the chopping block in Congress 5 years ago now or something, and in the absence of that, none of these buildings would be retrofitted. The apartments that we get to build in them would not exist, and the community and economic development benefits that come as a result of like resurrecting these otherwise vacant and vandalized buildings, wouldn't happen. So it's a delicate balancing act. I don't mean to I think this is recorded, so if SHPO is listening, like I don't mean to belittle their priorities at all. Obviously, WIN does a lot of historic adaptive reuse projects, and we love it, and we're really proud of those projects more than anything else we do, and don't want to rock the boat. But we do feel really strongly that Stone Mill is an opportunity to really showcase how willing NPS and SHPO have been to work with us. So the simulated double hung window, for example, assuming it's going to be approved, it was not in our conditional part 2 approvals, you know, is I think pretty innovative, and they're being flexible with how different the dimensions are. So they have a 1/4 inch tolerance on your window frame, and we're off by 1/2 inch. So it's 2 times what they would normally tolerate, which is a big deal. And I think I should give credit to a project in Fitchburg, Moran Square,
Right.
that's similarly been working very closely with NPS and SHPO, and have managed to get quite a bit of sort of unique details approved. And I like to think that SHPO, especially in Massachusetts, knows that we're trying to build high performance buildings that are durable and comfortable to live in for the next 50 years and don't rely on fossil fuels. And that might mean we see a shift in where they're drawing the lines in some cases.
A quick follow-up on that. I'm interested in what their attitude toward the hopper window is. You have a simulated double hung, but it's now a hopper. And
yeah, it's my, sorry, I just saw Ken's comment. That's insane. Yeah, I mean, that's the question. They seem, that's the least of their worries. The meeting rail and our muttons and getting those exactly right is more relevant to what the window looks like when it's open. I didn't question that because I desperately want to use a hopper window, but it was surprising. But I think because it looks like a simulated double hung, it reads like the historic operation when it's closed, they're comfortable with it.
yeah, great.
Michelle, I think your hand, yeah, go ahead.
Thanks. Yeah, awesome presentation, Christina. Love what you're doing for sure. And really interested in air tightness. And so a lot of what you're focused on here is dealing with things from the inside for obvious reasons. That's a place that we all are often living, and also often occupied. And so I see the interior wall, I see some rigid insulation. I'm sure there's some ceiling going on there, but I'm interested in, is there anything special, anything other than just the insulation layers that's going on in these projects from an air tightness and air sealing perspective on the inside? And is that different when it's occupied or not? And I'm thinking about aero barrier and, you know, other things. I
Yeah.
mean, we want the solution that, like, you know, what's going on?
We I mean, this is the good thing about spray foam. It's also our air barrier on these mill buildings. But when we can't fur out the wall and we leave the existing exterior envelope there, we are paying a lot of attention to taping and caulking, you know, demising walls, corridors in between apartments, for compartmentalization there. On the exterior, we're not losing a lot of air through however many courses of brick and block, sort of thick these walls are. But when we've said that every mill building should be able to achieve a 5 ACH compartmentalization blower door test, and we generally come in around 3. But in some tricky units, like a corner unit or a unit with a tongue and groove, you know, wood ceiling that's full of air pockets, and it's coming in anything over 7 ACH, we have been using aero barrier. and trying to catch that early with some mock-up testing. We've only done that now twice, and we haven't done it sort of building wide in every apartment, only in the worst performing units. So Clear Result actually just recommended air barrier for, I think, 11 apartments in a mill that we're finishing up in New Bedford right now. That just, no matter what the GC tries, we cannot get below 7 ACH. No one cares what no one's telling us any number. No one asks for the blower door test. It's not a requirement of anyone. For the record, historic preservation projects are exempt from energy code compliance. Maybe a relevant point worth mentioning. So we don't actually have to do anything, but we started at 7 when I first started, like 10 years ago, and we were always beating that. So now we just put in our specs that we want to hit 5, and again, we're usually beating that. But if we're missing it, Aero Barrier has proven to be an amazing product, but it's expensive and it's really hard to cut costs elsewhere to justify. So what I want Aero Barrier to figure out is to say your plumber, your electrician, your HVAC contractor, and your sheetrock sub, they can all do like a C- job and cut all of their costs by like 20%, because we're going to come in afterwards and do it all for them. And it just, there's no way to
awesome.
communicate that to them, because they own fire stopping all of their penetrations, and they're taping and mudding and finishing the framing. And so it's hard to sort of say, okay, well, target a 10 ACH because we're going to come in and fix it afterward. And I want to see a savings on that because I'm paying $1,500 a unit for Aero Barrier to come in before you put the finishes in. So it's always a cost add. It's like like AeroSeal. It's generally carried as an add alternate, and we only do it if we need to, i.e. we fail. So to this day, AeroSeal is not, we try to pass without it. And the GCs try to hold their subs to it. And then if they fail, the subs or the GC eat that cost because they failed, rather than carrying it up front. I don't totally understand the strategy there. They're sort of trying to prove that they're better than the invisible glue, but they're passing in some cases without it. So I'll give them that. Including the project we just finished up with Icon and Lowell. They got all of the ERV ductwork fully balanced and passed all of the duct leakage tests for Energy Star certification by New Ecology without air sealing the ductwork. But yeah, I mean, the occupied rehabs, it's impossible. Blower door tests are generally pretty bad, and that's why these exterior cladding projects are so important. So we're insulating them and tightening up the envelope from the outside.
Yeah, thank you.
I haven't seen what Aero Barrier does to people's couches, but I have seen it on cabinets and then just sort of scrape it off. So I wouldn't want to do it in an occupied setting.
Right. Talk to Luke McNally. He did that.
Yeah,
one.
that's what I've heard. Exactly.
Oh
boy,
here, so
okay.
we'll chime in here.
If you can hear me, I will chime in. Yes, yes, I did indeed do Aero Barrier in our occupied, fully furnished home, and it did require us to completely encase everything in plastic prior, and then do many months of cleaning up sticky stuff afterward. I strongly recommend it when you are moving out and ideally gutting the place prior. But it did help, and I unfortunately do still have some large gaps that I couldn't get to, and so I couldn't get down to my goal of 1 ACH. Anyway, close, but not quite there.
We're running up to our time here tonight. Christina, I want to thank you so much for being here and putting together this presentation for us and taking the extra time to kind of answer some of these questions. The work you're doing is tremendous, and whether you're getting these certified as Enterfit projects or not, you're getting close to those numbers. In some cases, you're hitting them, and it's fantastic to see. And you're kind of paving the way for what we're trying to focus on here in Massachusetts, of getting more of these old buildings retrofitted into better performing places to a better energy performance and just be more comfortable and healthy. So thank you for leading the way in that. And we hope to see more of you here in the future and present on more of these projects.
Thanks for giving me. Yeah, thanks for giving me the opportunity. I mean, there's lots of people on this call and part of PHMass Massachusetts that taught us everything that we're doing today. And every project has a long list of logos and team members. So if I didn't mention anybody, I apologize, but it is always a big team effort between the architects and engineers and contractors and all of our favorite sustainability consultants. So thanks. Hopefully we can present on maybe a PHMass certified stone mill next year.
Great.